welcome back. We're going to finish up this project for the degree wheel base for the Honda. And what we got to do today is we have to put two holes in here tapped so that our cover plate, and we're going to put two relief holes in here, or clearance holes for the screws to go through. So when we put the degree wheel on there, it'll sandwich it or capture it on the base. Okay, so I'm going to set it up in a V-block and I'm going to, both of these outside diameters are exactly the same size, so I'm going to set it up so I can remove one and put the other one in, and then flip it upside down, because on the back side where it fits the crankshaft we have to put a little keyway slot in there for clearance, so that when it goes on the crankshaft it doesn't interfere. So that's what we're going to do today. The distance from center on either side, and what I did was I calculated the center of this feature right here, so that the hole will go right in the middle. That way I don't break out into either end. The center is 1 inch 536 thousandths, which is 768 in either direction once we find the center. We're going to make it 1032. I decided to go with 1032. So we're going to be using a 21 tap drill and a 10 clearance drill in the plate on the front. Then later we're going to use a 187 end mill, and we're going to come in and we're going to make that little feature for the clearance for the keyway. Okay, so pretty simple. What I'm going to do is I'm going to come in here with a very small center finder, and I'm going to find the center inside this hole. I'm not going to worry about dial indicating it. It should be close enough, but I'm using a tiny center finder. And it doesn't matter where on this radius that you find the edge, because as long as you go to the other side and find the edge again and divide it in half, you will be in the center. But I'll do it a couple of times just to make sure I'm dead in the center. And then we're going to put those holes, we'll offset it and put the holes in. Okay? And I'll have my center for flipping it over and putting my keyway in, and I'll locate it off the same outside radius that I'm using now. I'm just going to stick it in a V-block. So, let me zoom in. So I'm going to set it up in a V-block. I got a little parallel on the bottom so that when I drop this in, it locates on the bottom. Later I'll flip the parallel up and put another one and drop this in the same position. I put the V-block in alignment with the back jaw. I'm going to put a piece of cardboard in here on the jaw. And I don't have to clamp it too tight. It's not going to really go anywhere. Alright, so I'm just kind of setting it up so that my tooling will be the in the same spot. I won't have to keep going up and down. I might have to move it a little bit. The light's in the way. Alright, so I got plenty of room. Alright, so now I'm going to use my half function on the digital readout. So that's half on my X. Sometimes if you're going too fast, the edge finder will spin itself true. Zero. Half Y. Oh, I did that wrong. Supposed to be Y half. Zero. All right, so that should be dead center. I'm going to do my X one more time just to make sure. And it's right on the bottom. So I'm going to lock the table in both positions. Actually, I'm going to have to move it. Alright, so it repeated, and we have it right in the middle. So I'm just going to offset it on my X. I'll lock my Y, and I'm going to offset it on my X. Both directions, because I'm 0 right now, I'm going to go positive 768 and negative 0.768. And that'll put me dead center of this little raised feature. Gotta grab the center drill. All right, so let's go 768. All right, that's 768. We'll just lock that. And I'm just going to bring it down, look at it, and I can tell that that is dead center. I can tell that's dead center. All right, let's give it a spot. I'm going to go more than deep enough so that I don't have to use a bottoming tap in here. I'm going to go just before I break out. I'm going to put a little mark on there so I know where it is. I'm going to mill it, move it, and drill the next hole, and then I'll drop the table and tap both of them. Alright, I'm going to lock the table, and we're going to move positive 768. Alright, so I'm going to drop the table and I'm going to put my tap in there with my tap follower. So I'm going to come down touch. I'm going to bring up my quill stop. And then I'm just going to peck at it. All right. See if we can get that to... That's all I was looking for. Just a little relief. And I just about touched that bottom. There's a couple of thousandths from it. And the key doesn't come out that far. All right, so this pot's done. It's finished. We're going to set up this pot. I'm going to put this in the same setup, and I'm going to do the same distance that I did over here. So bring it back when I'm set up. All right, so we put this in, made sure that our V-block was right up against the edge of the jaw, put the parallels up in here, and I brought it back to center, and then came over 768 thousandths, and we'll drill our clearance holes. Right, move 768 the other direction. Alrighty. All right, I'm going to take it out. I'm going to bring it over to the bench. I'm going to use the Noga on the holes, and then we'll see if we can find a couple bolts to put in there and make sure it fits right. All right, I'll see you back at the bench. All right, we're back at the bench. We're all finished. Just to give you a little look at how this is assembled. So this would butt up to the face of the crankshaft. Got your keyway relief. Okay. The bolt goes down in here and it tightens it up against the crankshaft. The degree wheel slides on the hub, and we take the faceplate and we mount that. Alright, so the idea here is that if any of you guys haven't used a degree wheel, is we have to degree the cam in relationship to the crankshaft so that the valve opening and closing events will coincide correctly with the position of the piston. And with high performance, you're going to set that camshaft up a very specific way, or you may alter it depending upon what you're doing with that vehicle on the street or on the track. So what you would do is you would crank your engine over until you locate the position of the piston on top dead center. Once you do that, you would not touch the crankshaft anymore. So the crankshaft would stay in that position. Then what you would do is you'd put a pointer over to the degree wheel, and with it being loose, I can rotate this around until I get the pointer to line up with top dead center. And then I would take it and just lock this down. Now, anytime I rotate that crankshaft, I know where it is in relationship to the 720 degrees of rotation for a four-stroke engine. I can then verify where my camshaft is with the dial indicator to make sure it is opening and closing at the proper time. And there is no real proper time. It all depends on the specific engine. There is a range of when they operate depending upon, you know, for a four-stroke engine. Depends on the camshaft and a lot of different variables. But this is one tool you would use to do that. Now, I cannot do a video on that because I teach this and I have a contract that doesn't allow me to do that. So, but I can do this. This has got nothing to do with the school. I made the hub, like I told you before. They have the tools that come with this. Like this one right here. It's got a real crappy hub assembly. They give you some plastic bushings to come in there, and it wiggles around a little bit. I mean, it works, but it wiggles around. And with the students learning how to do this for the first time, fighting with this stupid thing is a real pain in the butt. It's just one more element to give them a problem. To have a hub like this, they can mount it on there. They don't have to screw with that. They can just do their job. They can learn how to do this, and they don't have to worry about all those other issues. You can buy some degreeing tools that have hub assemblies on them. They only do so many different cars. They're not 100% universal. We do have some of those hubs for this wheel for the traditional American muscle cars and muscle engines. When it comes to the imports, there's not a lot out there. So the universal kit comes in handy when you're trying to do that. It doesn't cost you any money because it comes with this kit. But this works really nice. And these kids are doing this over and over and over, and I'm doing it quarter after quarter after quarter. So it makes it a lot nicer and easier for them to learn the task at hand. So I got some pictures coming up of it mounted on an engine, not 100% mounted, no point or anything, but just so you can see how it gets mounted. And I will put that right after this video. Again, I want to thank you guys a lot for making this channel a success. We're almost 200 subscribers now, and that's big for me. So I hope it keeps growing. Please like and subscribe. And when you like, hit the like button. It helps share the video, and YouTube will suggest the video more and more and more, and it helps get it around. So again, I thank you guys for watching. We do have another project coming up, and it's another school project. So basically what it is a little preview, is we have to make a piece of a tool for a dial indicator. These dial indicators, you know, the ones with the snake or the flex arms. This one is a real piece of junk. But I came up with an idea to fix this, and that will be the next video. And we have like 5 or 6 of these, so we don't want to throw them away, but they all have the same problem. Okay, so I'll see you in the next video. Again, thank you very much. Have a good day.